Now see. So before trigonometry, I generally start with this thing called similarity of triangles. Abir, are you there?
Yes, sir.
So these are the two triangles which are similar. Arjun, by any chance you know properties of similar triangles?
Sir, I've done this with you, but I don't exactly remember the
You could
properties.
have said that I don't know only. Why you said that
Yes.
I have done it with you but still I don't remember?
Uh, Sorry.
तो अलग ही हो गया क्या अरे properties of similar triangle, what can you see? At least one thing तो you can see. What is it?
Relation to sides.
Angle first.
They have same angles, they have different sides.
They have same
Same
angles.
angles, they have different sides.
So all the angles are equal. That means what? Angle A is equals to angle P, and obviously these are corresponding angles. Like I won't say P is equal to B, and this angle is equal to this angle. That is one property. But the second, which is a very important property, is that the ratio of the sides are equal. Meaning, AB upon BC, AB upon BC is equal to PQ upon QR. Is equal to PQ upon QR. Correct? Then we have AB upon AC, right? Probably this AB upon AC is equals to PQ upon PR. And what is left here? AC upon BC, like this AC upon BC is equals to PR upon RQ. So this is one of the major properties of similarity of triangles. Like all the sides are in proportion, and the second thing, all the angles are equal. That's the property. Now, what else we have in this? So for example, I'll take an example. Let's say this is 3, this is 7, this is 10. So, and there is this huge triangle which is somewhat like this, and both the triangles are similar. So this could be 6, 14 and 20. So as you can see, 3 by 10 is equal to 6 by 20, like this, or 7 by 10 is equal to 7 by 10 is equal to 14 by 20. Did you get it? Even this would be similar, 140, 260, like that. Got it, everyone? The basics are clear. Similarity of triangles, right? Now what if I consider a right angle triangle, something like this, okay, and another one like this? So I would say this is A, B, C, this is A dash, B dash and C. This is the angle theta. Now my question to you is, one second, keep.
Yes, sir.
Okay, Raj, tell me, so are there any triangles which are similar here?
A, B, C and A complement C, B complement C.
A, A dash, B dash, C, they
Yeah,
are similar, correct? So why they are similar?
because they have the same angle ratio, but uh, it's just the
Alright, tell
sides
me
are
test. You guys don't even remember the tests. Huh? Vidhi?
Yes, a
right side angle. No wait,
I don't know. Like this, I get confused between neutrons and similarities one thing.
Arre, the best test of similarity of triangles is what?
angle.
Ratio of the sides and the angles
The
are the
best
same.
one is just angles are congruent. Here
Yeah,
the angles are equal,
Angle.
na?
yeah, that's right. Ratio of the sides and the angles are the same.
Arre, sides we don't even know here.
No, only A.
Oh yeah,
I'm just
fine.
saying
Yeah,
that the triangles are similar. Why? Because as you can see, angle ACB is equal to angle A dash CB dash, and also angle ABC is equal to angle A dash B dash C. So those two angles are equal. So obviously the third angle has to be equal. So that's why the two triangles are similar. Now, if the two triangles are similar, that's why using these properties, I can write AB upon AC is equal to, like, see, AB upon AC, correct? AB upon AC, pay attention everyone, this is very important. AB upon AC is equals to A dash B dash upon A dash C, correct? Similarly, BC upon AC is equal to B dash C upon A dash C, correct? And finally, AB upon BC is equal to AB upon BC is equals to A dash B dash upon B dash C. A dash B dash upon B dash C. Everybody got this thing? Anyone who is having any doubt, let me know if there is even slightest doubt, whatever if you have. Fine? Correct? Because of the similar, see, because the angles are equal, that's why the triangles are similar. Because the triangles are similar, that's why these sides are in proportion. Now, this would be valid for each and every triangle, like this, and like this. So all the huge triangles will also have the same thing. So what exactly is happening? Understand this thing. This is like, it is 2 and this is 4. So this is like 10 and this is 20. So AB by AC is 2 by 4, but A dash B dash by B dash C is 10 by 20. But at the end, both are 1 by 2, 1 by 2. So they are in proportion. Correct? So now see, here, look at this thing. This is a very important information. So obviously, I can change the triangle like this. I can have infinite triangles like this, like this. The size of the sides are changing, right? The sides of the triangles are changing, correct? But what is something which is not changing?
The angle.
The angle theta. And that's why we will give a lot of importance to this theta, and we will introduce to the 3 trigonometric ratios, which are trigonometric ratios. Ratios means AB upon AC, BC upon AC, AB upon BC. But since I want to give a little bit importance to theta, so I'll represent these ratios in terms of angle theta, and those are nothing but your sine theta, cos theta, and tan theta. And that's how you got these ratios. Correct? Right? And obviously, in general, for any triangle, see, understand, these all triangles, how many triangles are there? There are 10, 15 triangles, whatever, this. There are many triangles you can make. All these triangles have different sides. Just focus on this thing, okay? Let's focus on AB upon AC, like AB upon AC. All will have different sides, but all will have the same ratio. Meaning, let's say AB upon AC is 1 by 2. So 1 by 3, chalo. 1 by 3 will take. The next would be 2 by 6, right? 2 by 6. 2 by 6. The next would be 20 by 60. The next would be 40 by 120. All these are just sides of the triangles. 2, 6, 20, 60, 40, 120, and so on. All the side lengths are different, but the ratio is same. And those ratios are nothing but your trigonometric ratios, which is sine theta, cos theta, and tan theta. So I can represent sine theta as opposite upon hypotenuse, right? Cos theta as adjacent upon, because B dash C is just or BC is nothing but the adjacent side to it. Obviously there are 2 adjacent sides, but one is hypotenuse we are going to consider. So this is going to be adjacent upon hypotenuse, and this is going to be opposite upon adjacent. I'll just write it properly.
I didn't understand all of this.
One second. What did you understand?
Like the sine theta and all, I missed it. My net was like glitching kind of.
You understood that the sides length are different, but the ratios are equal.
Yeah, that
ठीक है? हाँ. So here in general, remember there are infinite triangles I can make. Right? So with respect to this theta, this would be side opposite, this would be side hypotenuse, and this would be side adjacent to it. There are 2 adjacent side, hypotenuse and adjacent, but obviously hypotenuse is the longest side. So that's why sine theta, cos theta, and tan theta are nothing but the ratios which are going to be, sine theta is going to be opposite upon hypotenuse, cos theta is adjacent upon hypotenuse, and tan theta is opposite upon adjacent. Correct?
Okay, got it.
ठीक है? Do you think there are other trigonometric ratios? I mean, you can think of any other, like, see, we already got opposite upon hypotenuse, opposite adjacent upon hypotenuse, and then opposite upon adjacent. 3 types of ratios we got it with respect to 3 sides. Can you form other ratios as well?
So there's something related to the angles, right? Like there's a different rule for sine and there's a cos rule or three sides of the now also, right?
नहीं नहीं नहीं, अरे वो सब छोड़ो यार. I'm just asking you, opposite upon hypotenuse, adjacent upon hypotenuse, opposite upon. Did I miss anything? Did I miss any other ratios?
No,
No.
so
Tell me.
hypotenuse upon.
Everything the other way around. Everything is
हाँ,
opposite.
correct. So
Right.
there are other ratios also. So opposite upon
Yeah.
hypotenuse. So you can think of this also. Hypotenuse upon opposite, right? Then hypotenuse upon adjacent, and then adjacent upon opposite. Any other ratios you can think of? No, that's it. So these are your 6 trigonometric ratios. As of now, you just have these 3. These are other trigonometric ratios. If you want to know, it is cosec theta. I don't have space. One second. This is cosec theta, this is sec theta, and this is cot theta. Other trigonometric ratios. You don't have, of course. You just have these. Okay. So there are total 6 trigonometric ratios. Majorly, if you see, sin theta and cos theta are important. Tan theta is not even that important. Why? Because think about it. Tan theta, if I want, I can write, like, I will divide numerator and denominator by hypotenuse. So it's going to be opposite upon hypotenuse and adjacent upon hypotenuse. So opposite upon hypotenuse is nothing but sin theta, and adjacent upon hypotenuse is nothing but cos theta. So if you see, the major trigonometric ratios are only sin theta and cos theta. Rest 4 trigonometric ratios I can just form through sin theta and cos theta, correct? Because these are just reciprocal of these. Like if sin theta is 1 by 2, so this is 2 by 1. So these 3 so you can form it through the reciprocal, and tan theta you can just find out using sin theta by cos theta. Got it, everyone? Now, of course, how this trigonometry is used, one of the best example is angle of elevation and depression, all of those things. So like if I want to find, obviously if I want to find the height of the Mount Everest, now I don't know, but not many people literally climbed at the top of the Mount Everest. Is it? No, no, I don't think so, right? So obviously, but we still know the accurate height of the Mount Everest, right? So obviously the thing is they use trigonometry, because I can find out this distance easily. Let's say this is 100 kilometers, right? Correct. And this is what we need to find height, right? Now obviously I don't know this distance, but I can understand this angle theta. This is angle of elevation, right? Like how much it is up, like this angle of elevation. So this theta, if we know, this theta, let's say, is 20 degrees. Now I know this is 20 degree, this is h, this is 100 kilometer, correct? Now what is the relation between, if we know the angle, like see, the whole point is that if I know one side of the triangle and just one angle of the triangle as in right angle triangle, then I can find all the sides, all the angles, everything, right? And obviously if I know one angle, that means what I want, I know all the angles. But if I know one of the sides, I can find all the sides. So if you know this side is opposite to it, this side is adjacent to it, so tan 20 is nothing but h by 100. So h is going to be what? H is going to be 100 tan 20. Now you have calculator to find out this thing, correct? But let's say if we don't have calculator, let's assume we don't have calculator, right? So how will you find tan 20? So what I'll do, simply with my scale and this protractor, whatever, I'll draw a small triangle whose angle is 20 degree. Maybe it would be like this. I will draw a triangle whose angle is 20 degree. Okay, right angle triangle. I will know this much distance, I will know this much distance. Okay, let's say this is 1 and this is 10 centimeters. So obviously this blue triangle is similar to this white huge triangle, correct? So I know tan 20 is just 1 by 10, so I'll just put 100 into 1 by 10 and I'll get what? I'll get 10 kilometer as my answer. So that's the height of the Mount Everest, correct? So that's the major application. Like of course, if you know, nahi, I mean I don't know whether you know it or not. This thing, क्या बोलते हैं उसको? I don't know the term, but if you want to calculate the distance of the stars from the Earth, so they use trigonometry there. Obviously, light years. Okay, light years का there is a different concept, but still, let's assume that we need to calculate 30,000 किलोमीटर 40,000 वो भी बहुत कम है crore kilo मतलब million billion kilometers whatever, so they don't calculate million billion kilometer by throwing a light and then understanding how much where it will reach and then getting the answer. Of course not, they're using trigonometry for that matter. So क्या बोलते something effect you call, it's like this when you put this finger here, so you see that on the left hand side and on the right hand side you get a different perspective. P से नाम है उसका, I don't remember, but that's how they use it. So there are many applications of trigonometry. Unit circle में तो there are many more applications. So as of now only triangle is important. So that's all you need to know. So everyone, any doubt in this? Obviously this, even if you don't understand, it's fine. When we'll do some of the questions you will understand. But this basic trigonometric ratios, how they are formed, like what are these values and all, you got it? Correct? Now what kind of a question? These are very basic questions, obviously you can get it easily, but you'll have to practice, otherwise you will make silly mistakes. So for example, I'm just taking some random question. Let's say this eighth one. They have given a triangle where this angle is 40 degree. Always ask the same question. What is the relation between this 40 degree y and 5.17? So y is opposite to it, 5.17 is adjacent to it. So what is the relation opposite adjacent? It's going to be tan. So tan 40 is going to be y by 5.17. That's it. Y is equals to 5.17. Obviously you have calculator, you can calculate tan 40. 5.17 into tan 40 and you will get the answer as 4.338. That's your answer. Centimeter, meter, whatever.
Excuse me, sir. So I think like we can craft the question also this time. No? So can you teach us how to use the GDC?
You got your GDC, everyone?
So mine will come by the way.
Yes, sir.
Zana, you got what? You got 6.95 for this, right? But logically
Yeah.
think m is hypotenuse, m is the longest side, so obviously it has to be greater than 8, right?
Yes.
So that's why you must have made a mistake. So now again do it. So sine 49 is going to be opposite 8 by m. So m is actually 8 by sine 49. You must have multiplied.
Sir, I got the adjacent instead of the hypotenuse.
Hmm?
So I got the adjacent instead of the hypotenuse.
Exactly.
So the answer will that be
Okay, everybody is getting it right, no problem. Arjun, what did you get?
so minus 8.38.
क्या?
Minus 8.38. 8
अरे
divided by sine.
नेगेटिव वैल्यू हाउ विल कुछ भी मतलब.
So जो कैलकुलेटर में आया ना
अरे तो बोलने से पहले सोचना तो चाहिए ना. अरे क्या, इज इट इन रेडियन?
So 8 divided by sine 49 to answer minus 8.38 आया.
सिंपल है, 8 बाई साइन 49. आई होप इट इज इन डिग्रीज. 10 पॉइंट कितना था? 10.1 है क्या? व्हाट इज इट? 10.6 है आरना, स्टिल 10.6.
So I didn't give the 20 का answer, I have 22 का 1.1.
अच्छा. ओ.
So,
हम्म.
Raika and Parisa are saying that tomorrow they won't be able to do class